Hello guys, welcome to my presentation. Today I have something new for you. I'm going to discuss 20 formulae for working out area of different figures. So these are just formula that one can use to work out the area of different figures. So if you are very new to this channel, do not forget to subscribe, like, and share this video to as many of your friends as possible. So I want to welcome you one more time to this channel, and thank you so much for those of you who have subscribed already. Now, the first figure that we are going to consider is the circle. So the circle is before us, and if you can look very well, we have got R. This R stands for the radius, and of course, this is the circle. Remember, we are interested in the area of this circle. So in your exam, you'll be given a number that is to represent R. So mine is just to give you a formula. So if you have been asked to give the formula of calculating the area of the circle, you will say that the area is in fact pi r squared. In this case, you are going to square the radius. You're going to square the radius, and of course, pi is 22/7, or sometimes they can tell you to use 3 point. Um, 3 point. If you divide that, it is going to give you three. I think 3.22. You divide by 7. It is 3.142. 3.142. If they have instructed you to use that as your pi. But in this case, it is 22/7 unless instructed. So the area for the circle is 22/7. 22. The area for the circle is in fact pi r squared. And for pi, I have mentioned 22/7. Unless instructed, somebody can go ahead and use 3.142. So that is the area of what? Of the circle. The second figure that we have is a semicircle. A semicircle is in fact a half of the circle. So what we are going to do to the area of the semicircle is in fact we take that area, we get we get a half the area of what? Of the circle. So the area of the semicircle is a half pi r squared. A half pi r squared, and here is the radius. You'll be given a number in your exam, for example. So the area for this is in fact a half pi r squared. So the next figure that we have is in fact the rectangle. The next figure that we have is the rectangle, and this time round under the rectangle we have got two sides. We have got two sides. We have, of course, the length. The length is down here, and the width is on the other side. You discover that these two sides are not the same. That is why we have a difference in measurement. This one will take a different measurement, and also the width will take a different measurement. So when that happens, we are going to say that the area for this is in fact length times width. If you get the product of length and width, that one will give you the area of a rectangle. The next figure that I'm going to mention here is in fact the square. If you look at the square, you discover that I've used S on both sides. It simply means that this side here is the same as the other. In fact, all the sides in a square equal. All the sides in a square are equal. Therefore, for the area, we will have to say that the area in this case is in fact side times side. For example, if you have 4 here, you will say that it is also right to it is the same 4 will appear on this other side. That is why we are saying side times side. The next figure that I'm going to present to you is a trapezium. And a trapezium, this is how a trapezium looks like. This is how a trapezium looks like. We have two parallel sides. That is this side up here and the other one here. They are parallel. So when they are parallel, we have another side here which is going to act as our height. So this is our height. In this case, you can take this height here, or you take the height on the other side. So if you are given a number on this other side, it is in fact the same as the height that I have inside this inside this figure. So we are going to say that for the area of a trapezium, we are going to get a half, and then we have to multiply by what? By the sum of these two parallel sides. Then we multiply by the height. Yes, you get the sum of the parallel sides, and of course you multiply that by the height. The product you get, or the result you get, you divide that by 2. It will give you the area of the trapezium. The next thing is a parallelogram. A parallelogram, if you check, I have H here standing for the height, and of course B here stands for the base. So for the area of a parallelogram, we will say that the area is in fact base times height. If you take base times height, it will give you the area of the parallelogram. The parallelogram is the area of a parallelogram is given in this way. So base times height, the product of base and height will give you the area of the parallelogram. So the next figure that I'm going to present is in fact the rhombus. The rhombus is here. You discover that the diagonals of the rhombus are going to intersect at 90 degrees. Therefore, I have labeled this one as my diagonal 1, that is for D1, and of course this other diagonal I have given it D2. So for the area of the rhombus, we are going to say that the area of the rhombus is going to be in fact a half of D1 times what? D1 times D2, half of D1 times D2. So if you get the product of the diagonals and divide that by 2, you're going to get the area of the rhombus. The next thing we are going to look at is triangles. So we have triangles, and in this case the first triangle that I have looks like this, whereby you have been given the base and of course the height is here. So if you have such a triangle, you will be forced to say that the area is in fact half the base you multiply by the height. A half base times height. A half base times height will give you the area of this triangle. We also have another triangle here. There is another triangle that I have. There is another triangle that I have here. There is another triangle I'm going to present to you. This is the triangle. This is the triangle. So for this triangle, you discover that you have been given a measurement for the 3 sides. You have been given the measurement for the 3 sides. Now that you have the measurement for the 3 sides, you are going to use a formula known as the Hero's formula. You're going to use Hero's formula, and the Hero's formula simply says that if you want to work out the area of this triangle, you have to say it is the square root. You will take the square root. You will take the square root, of course, of s of s. I'm going to show you how you are going to obtain this s. S, of course, you open the bracket. The same s, you are going to subtract a, and of course you multiply this by you open the bracket s, you take away b, you also multiply by s, S, you take away C, which is our which is our final measurement that we've been given, or the last measurement that they have given us for this figure. Now, how do you arrive at the S? For one to be able to get this S, first of all, you need to get the perimeter around this figure. And the perimeter, remember, for you to get the perimeter, you are going to take perimeter, you are going to take, you are going to add, you're going to get the sum of A plus B plus C. After getting the sum of A plus B plus C, you will divide this sum by what? By 2. You divide the sum by 2. If you divide the sum by 2, you're going to get your S. So that is how S is calculated. So S is in fact half of the perimeter. Half of the perimeter will give you S. After you have obtained the S, you proceed to the formula that is known as Hero's formula. The third one, the third triangle, looks like this. We have been given an angle that is theta and the two sides, of course, A and B. So if you have a triangle like this and you want to work out its area, you will say the area is in fact a half A B. AB simply means that it is the product of A and what? And B. AB, the sine of what? The sine of theta. The sine of theta. And theta in this case is just an angle. You will be given an angle in your exam. You'll be given an angle. So that is those are the three formulae that you can use to work out the area of triangles. The next one is a rectangular pyramid. The next one is a rectangular pyramid. And in this case, you discover that under the base we have length times width. It simply means that the measurement for length is different from the measurement of width. That's why it is called a rectangular pyramid. If this is the case, and you have been asked to work out the surface area of this figure, then you will have to say that the surface area of this figure is going to be, first of all, you get the area. You will count the number of triangles that you have. For example, in this our figure, we have 4 triangles. You can count. This is the first one. So the one that is in existing here is also at the back. So we have 2 of them, and the one that is here is at the other side. So we have 4 of them, 4 triangles. So we have 4 triangles. So the first thing that we are going to do is to work out the area of one triangle. If you work out the area of one triangle by using the formula a half base times height, that is for one triangle, you multiply by the 4 triangles that we have. So you multiply by 4 triangles. So this thing that I have used simply stands for the 4 triangle. So you multiply by the 4 triangles that we have in this figure, and of course you add that one to the area of the rectangle, because the base area, or the base is a rectangle. You multiply by the you add to the area of the rectangle. You add the area of a rectangle. You add to the area of a rectangle. If you do so, you will arrive at the surface area of this rectangular pyramid. So the next thing is a square pyramid. Square pyramid, we are going to now change the formula a little bit by saying that the base is a square. That is why it is called a square pyramid. So we are going to find, instead of a rectangle, like what we did in number 9, under number 10, the base is what? Is a square. So we are going to get the area of a square. Then we add to the area of the 4 rectangles. So we are going to say the surface area for this is going to be a half base times height. You multiply by 4 by the area of 4 what? Triangles. You multiply by 4 triangles. And then you add to the area of the square base, the area of the square base, the area of the square base. So the next one that I want us to look at is a cube. A cube looks like this, and all the sides of a cube are equal. All the sides of a cube are equal. All the sides of a cube are equal. That is why I have side times. It simply means that this side is the same as this side. Okay? Side times side. So for the area of a cube, we will say that area of a cube is going to be side times side, side times side, and of course we count the number of faces that we have here. How many faces are here? This is one face, the second one is there, we have the third one, the fourth one, the fifth one, and sixth one. So we have 6 faces. So after working out the area of one square, you multiply by how many squares? 6. Or how many faces? 6 faces. 6 faces. We have 6 faces. You multiply by 6 faces. So that one will give you the area or the surface area for that case, the surface area of a cube. What about a cuboid? The cuboid is here. The cuboid has got a different measurement and a length, a different measurement and a width, and a different measurement and a height. So if that is the case, it simply means that we are going to count the number of faces and of course apply a different formula for that case. And this is the formula that we are going to use. We are going to say that for us to work out the surface area of a cuboid, then we will have to say that this side that is here, length times height, it is also appearing on the other side. If you can look at this figure very well, you discover that even this other side we have length, on the other side we have what? We have height. So it simply means that if we find the area of this of this one face, we will have to multiply by 2 because we have 2 faces of the similar kind. So we are going to say that it is 2 we multiply by length times width. Okay? Why 2? Because we have 2 faces. This face that is here is also appearing on the other side. The same applies to what? To width and height. The width and height we have on this other side, it is the same as width and height we have on this same face. So we are going to multiply by 2. So we say it is 2, we multiply by width times height, and of course the last bit or the last phase that we are going to deal with is in fact length times height. The length times height we have on this other side, the length times height we have on this other side is the same length times height we have on the other side. Remember, the length times width we had at the bottom part is the same length times width that we have at what? At the bottom part of this cuboid. So the length times width we are having here is the same length times width that is appearing on the other face. So we are going to say it is 2 again. You multiply by the length times height. And that one will give you the total surface area of a cuboid. The next one we are going to look at is a cylinder. A cylinder, you discover that we have got the radius, under we have the circular base, and of course we are having the length on this other side. So for us to be able to work out the area or surface area of this cylinder, and we want to assume that it is a closed cylinder, we are going to say it is going to be 2 pi r squared plus 2 pi RL plus 2 pi RL. 2 pi R squared plus 2 pi R. The area of two circular bases plus the curved surface area. The area of the two circular bases plus the curved surface area. The next one we want to look at is in fact the next one is the sphere. The sphere is here. This is the sphere that we have. So for the sphere, we want to say that the area of this sphere is going to be 4 pi r squared. 4 pi r squared is the area that we can use, or is the formula that we can use to work out the area of the sphere. Very well. So the next thing that we want to look at is a half of the sphere, namely the hemisphere. The name given to a half of the sphere is the hemisphere. So for the hemisphere, this is the hemisphere that we have. This is the hemisphere that we have. For the hemisphere, it is a half of the sphere. So we are going to say that the area for this is going to be area is equals to a half the area of the sphere. A half the area of the sphere. Or somebody can go ahead and say it is in fact 2 pi r square if you simplify further. So it is the same thing. If somebody uses a half times 4 pi r squared and somebody uses 2 pi r squared, they are all going to arrive at the same answer, So the next thing that I want us to look at is in fact a cone, the cone. The cone. The cone in this case, it is also made up of a circular base, and of course, for that reason, the surface area of a cone is going to be pi r squared plus pi rl, pi rl, pi rl. For this case, pi rl is in fact the curved surface area of what? Of a cone. And pi r squared is in fact the area of this circular base. This circular base that we have will take pi r squared, and of course the curved surface area will also take pi rl. The next thing that I want us to discuss is in fact the frustum. The frustum is here. So for the frustum, we need to first of all identify. There are things that we need to identify. We need to identify the bigger radius in this case. The bigger radius, as you can see, it is represented by capital R under this diagram that I have. And the small radius is represented by a small r. The small r here simply means that it is the radius of the cone that was removed. So this one is small r for the radius of the cone, and this one is capital R for the radius of the bigger cone now, the bigger cone. And of course, we have small h for the height of this cone, and of course, we have the bigger h. The bigger h starts from C all the way to O2. From C to O2, we have the bigger h. In other words, the bigger height for that frustum. And of course, we have got the bigger slant height for this figure starting from C. So the bigger h, like I said, bigger h from C all the way to O2, this one is bigger h. And the bigger slant height is starting from C all the way to A. This one is the bigger slant height represented by capital L. Capital L. Small l simply means that it is the smaller slant height for the cone that was removed from that figure. Good. Now, we have to write now the surface area of the frustum. So the surface area of the frustum is going to be, first of all, it is the curved surface area of what? The curved surface area of the cone, the bigger cone, the curved surface area of the bigger cone minus the curved surface area of the smaller cone, represented by pi r L capital. All these are capital. R is capital. Remember, R is capital and L is capital. Okay. So This is the curved surface area for the bigger cone, and we take away the pi r l for the smaller cone plus the area of the two circular bases represented by pi r squared plus another one that is pi r squared plus the area of the two circular bases. So when you have that formula, you can easily find the surface area of what? The surface area of the first term. The next one is in fact sector. This one we have a major sector and the minor sector for that case. For the major sector, this area starting from this point, let me use maybe letters and say maybe this is A, this is B, and this is C. So this from A, B, C, that one is called a major what? Somebody can say a major segment. Somebody can say it's a major segment. And from ABD, this is a minor segment. So if you want to work out the area of a major segment, let's say area of major segment or sector, major sector for that case, if you want to work out the area of the major sector, you will be forced to say the area is in fact theta. You will have to take theta 1. I want to assume that you will be given an angle here in the form of theta 1. Theta 1 simply means is the angle that you've been given. So for you to be able to get theta 2, you will take 360 degrees. You take away theta 1, and of course you divide by 360. When you do so, divide by 360, and then you say pi r squared. So that is the area of the major sector. What about the minor sector? Area of minor sector. For the minor sector, we are going to take theta 1. It is in fact theta 1 over 360 pi r squared. Theta 1 over 360 pi r squared. So the next thing that is in line, and of course this is our very last figure that we are going to discuss. Please, you are very new. If you are very new to this channel, do not forget to subscribe, like and share this presentation to as many of your friends as possible. So the last figure that I'm going to discuss is in fact made up of two circles that are intersecting at a common point. They are intersecting at a common point. And if you can look at the circles, you discover that for circle 1, the smaller one, it has got a sector, of course, and this sector, the radius for this is R1, and of course the R1 that is appearing up here is the same as R1 that is appearing down there. And of course for the second one, the bigger circle, we have got the radius, a different radius, of course, represented by R2, and of course the R2 that is appearing up here is the same as the R2 that is appearing down here. We have different angles, that is theta 1 and theta 2. I in fact intentionally used theta 1 to differentiate the angles. That is, this is angle 1 and this is angle 2. If you have been asked to calculate the area of the shaded region or the area between the two intersecting circles, therefore, you will be forced to say that for that case, it is going to be, let us say maybe this is circle 1. Let's say maybe this is circle 1. So the area for circle 1 is going to be, in fact, theta over 360, that is theta 1 over 360 pi r squared minus the area of the triangle, given by the formula a half AB sine theta 1. AB simply means R1 and R2. AB simply means R1, R1 simply means R1. That is R1 times R1. It will give you AB, is the same as AB. And of course, if you get that, you will have to add to the area of circle 2, which is the same. It will take the same format, but this time round, we are going to change the theta, and of course, the AB is going to be different. And we are going to say plus theta 2 over 360 pi r squared minus a half AB sine theta 2. So when you get the sum of area of circle 1 and area of circle 2, it will give you the area of the shaded region. Thank you so much for watching. Do not forget to like and share this video to as many of your friends as possible. Thank you.